From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 294, recorded live Monday, November 21st, 2011. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. In this episode, Scott talks with Matt Florence and Amir Rajan about understanding BDD and NSpec.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes. And today we've got Matt Florence and Amir Rajan from Improving Enterprises in Dallas, Texas. These are the NSpec guys. You are the NSpec guys. NSpec.org. How's it going, gentlemen?
Good. How about yourself?
Not too bad. So NSpec.org says BDD style unit testing in .NET, and it doesn't tell me what BDD is. I got to click on a link, and it tells me that BDD is behavior-driven development. Matt, why do I care about BDD?
Behavior-driven is sort of an evolution of test-driven development, where test-driven development focused the implementation of the test was closely tied to the implementation code, your classes and your methods. Behavior-driven kind of takes a step back from that and tries to approach the problem of expressing specifications in a more meaningful way.
And whose behavior do I care about? Is it a person's behavior, or is it a soft piece of software's behavior, or is it the system's behavior?
Yeah, I mean, it definitely depends at different levels in your application. You can write integration tests, and that answer would change. But something that perhaps a business person or a user would actually make some sense of.
You know, it's just really about writing a valuable test. When I've done unit tests in the past, I found that I was too concerned with just trying to get everything isolated as opposed to solving the real problem, which is working software. So just taking that little spin and saying that behavior-driven development is just about writing a valuable test. It's about testing how what the software is doing as opposed to how it's doing it is probably the differentiating factor for me.
That's a really interesting thing. So a lot of people have tried to explain this to me, and I've seen lots of different articles and papers that are more academic and blogs that are more kind of populist, everyone trying to explain BDD, but you're saying it's about writing a valuable test. So if I just go and get NUnit and start writing tests and doing test-driven development, kind of classic TDD, why does that have less value than a behavior-driven test, Amir?
So I guess the best way I like to explain it is that I don't think of, at least right now, I don't think of tests anymore as unit or integration tests. I just think of them as coarse-grain or fine-grain tests. And what I've found is that getting rid of that delineation makes it easier to write specifications like that. And we actually write, inside of the NSpec test suite, we have context spec or BDD style tests written in NUnit. And they're just really around just getting the behavior down and not really concentrating on how the intricacies or the inner workings of some component behaves. It's just about what the system does as a whole.
That's interesting. I've usually thought about things in terms of integration testing, unit testing, customer acceptance testing. And you're saying fine grain and coarse grain. Do you mean like testing little stuff or testing larger, how the system fits together type stuff?
Yeah, I mean, pretty much. It's about, let's take validation. Maybe I do a lot of testing with ASP.NET MVC. So maybe it's better to test the controller action all the way to the database end to end because that tells a better story than testing just a validator. And I'll choose that test. I'll choose the coarse grain test over an isolated test around maybe user validation or registration because it tells a better story.
Even though there's a lot more setup to be done in a test like that?
Yeah, maybe Matt can elaborate on that.
Well, I was going to change gears a little bit. There would definitely be more setup in that scenario, but I wanted to go back to something Amir said about what versus how. I think most of your listeners, most of the .NET world, works every day in an imperative paradigm, and so the how is so much more in our face and in front of us instead of the what. And so I think that's one thing that a behavior-driven approach makes you think more about. In other words, one of the ideas is your specifications are expressed in sentences. And so just taking that step back and declaring what your software should do, I think is a very valuable step.
Okay, so that's interesting. So you pulled us back to this idea of what the goal is, as opposed to the little internal details of, how I sorted this array. So some unit test might be checking that some array is sorted correctly, or that I'm doing some small detail-oriented bit of code correctly. But you're thinking that the larger, why is this being done, and how does this move the business forward is how I should be thinking about my specifications?
I think it's a very helpful way to pass on intent to the future software developers that are going to be maintaining your system. A good example is most recent blog entries should be on top. And you can do that in an in-unit style. And as Amir mentioned, our test suite for NSpec is written in in-unit and does a lot of that. But I wanted to come back to that declarative and the what versus the how, and just give an example. The most recent blog should be on top.
And as far as the setup, when you were talking about it'd be more setup, sometimes I feel that setup is necessary. If I isolate everything to where I'm only testing maybe the controller, I'm only testing a validator, and I'm not doing this end-to-end test, what I'll find is that I've done these these unit tests that are isolated, but when I start up the app and work on maybe the front end, I find that really I haven't done anything. I haven't actually set up my database. I haven't created any schemas. So that's what I use my test for, is to force the creation of a schema or force the creation of something. And testing things in isolation may not force that database to be created or force that table to be created. So sometimes that setup is necessary. And then what I find is that maybe after I've done a lot of the upfront coarse grain tests, there might be some intricacies that I want to isolate. And at that point, I'll go with a more fine-grained test, and it will be more of a unit test as opposed to the end-to-end.
How often do you build tests of tests? Like if you describe putting together a larger system and testing something like he just said, the latest blog post should be at the top. All of the setup and all the things underneath that might be tested as well. Do tests drive other tests and kind of nest, or should they all be peers of each other and have a lot of repetition but more isolation?
So that's really interesting. That's one thing that I think NSpec really excels at. And so the first part of it is, yes, you'll find that when you write some tests, it will drive out more tests to be written. And it's the idea is always to go with a naive implementation. Get the simplest thing in place to get the application working. And what you'll find is that you'll do the simplest thing, and as developers, we naturally maybe do null checks or many different things. Like if we're working with a dictionary, we'll make sure that the key doesn't exist before we insert the key. Those kind of things will get flushed out by the naive implementations that you write. So it may be more to say that when we write our context spec or our specifications, they're driven by naive implementations of the actual working piece of software. And then another thing that NSpec really excels at is that keeping things dry. The one challenge that we had with NUnit was we would have common setups that would exist, and just the structure of how NUnit does its setup and teardowns, it really didn't support this need to not repeat ourselves. And that's one thing that NSpec really helps with.
So a lot of people think that they're doing things right if they've set up automated tests. They've written their tests, and then maybe they put some continuous integration together, and they think, I've arrived. And then other people make a differentiation between there's writing automated tests and writing tests and test-driven development. But they might think that, that becomes kind of very woo-woo, if you know what I'm saying. And it's like, test-driven development, that seems right, like a philosophy or a religion or a cult of some kind. I've got tests, I'm fine. And then BDD seems like the next logical extension of test-driven development, giving some more thought to why you're testing things. But because it's upstream of this kind of larger kind of woo-woo cult, I think that sometimes it's not accessible to the average programmer. Matt, I mean, do you follow what I'm saying?
Yeah, I do. I think what you're getting at is writing your test first is hard. And it's actually impossible if you already have an existing application for which you don't have tests, right? And a lot of us are stuck with that in our day-to-day coding lives. So it is really hard to say you must always write your test first. And so I definitely, I'm aware of that perception of it being sort of a purist or an elitist or whatever opinion out there.
Well, inaccessible, I think, would be the better word, rather than thinking about it in terms of a class system of elites versus non-elites. It's not the obvious kind of like fall into it. I mean, anyone can go file a new project, but not anyone can sit down and write a good, test.
Definitely. I think what I would say too is, I know both Amir and I have gotten a lot of mileage out of doing code kata, and hopefully your listeners are familiar with that. We can talk about that more. But I think it's a valuable way to take a break from, the code that you're stuck with at work and seeing what really happens when I write a specification first. And I think what people will find is that they will expect their implementation code to behave better than it really does. And so for me, it's been a real humbling and I guess an incredibly valuable feedback cycle to write that test first, make it pass, and as Amir mentioned, with a very naive implementation. And what that forces me to do is elaborate my specification. And I found that yields designs that I wouldn't have come up with otherwise. Simple, very elegant designs in many cases.
Well, you've brought up this concept of the kata, which I think is, not everyone I think is familiar with that. The idea of a kata comes from martial arts. It's a Japanese word that means form. And these are the motions that you see people who are practicing martial arts kind of going through, and they'll do these patterns, most often on their own. And code kata is a similar kind of a thing. You might think you know a martial art, you might think you know a particular skill, but still you go through the motions and the forms and remind yourself of the fundamentals. And code kata is a really great way to sit down and do some focused personal time to make sure you know what you think you know and develop a muscle memory and familiarize yourself with the fundamentals. You guys both think that that's an important thing for people to do?
Absolutely. I think, and I'm not a student of martial arts, and I think that the metaphor breaks down. For one reason, software, it's meant to be very malleable and very, you can put together the same program to solve a goal in an infinite number of ways. So that's one of the really interesting aspects of doing the same code kata over and over again is you'll realize there's these junctures. If I had done that a different way, what would happen? And so you kind of get to practice these. If I implement this requirement before that requirement, what happens? And you gain a lot of insight into building really simple systems when you practice that.
And Amir, have you found that kind of clarity that one gets from that kind of practice goes into your tests? I mean, you really need to sit down and think. You don't just start slapping out a BDD type of a test. Because the behaviors that you're thinking about and the goals are driving the design of the software, there's a certain amount of consciousness and awakeness that needs to be happening when one's writing tests like this, wouldn't you say?
Yeah, it gets, and that's what the katas really help with, is that usually the problems are really simple. And, the biggest criticism I get when I do a code kata with someone that hasn't done one before is that, oh, this is so easy, I can code this out without writing any tests at all. And what the code katas have really helped me do is keep the problem simple and get that muscle memory in place. So what happens is that when I go to a real system and there's really complex problems to deal with, I can think back to my code katas and say, well, maybe I should try the naive implementation. What's the easiest thing I can do to get this thing to work? And then build from there. And that's personally how it's helped me become better at software development. Another thing is that you get really addicted to the feedback loop. Anytime you save a class, you get the failure come up, and then you go and make the test pass. You get into this rhythm that gets really addicting, and then when you go back to your everyday code, you want to have that rhythm back, and it helps you strive towards getting your everyday code to fall into that same I guess metronome.
This episode of Hansel Minutes is brought to you by Careers 2.0 and our friends at Stack Overflow. Careers 2.0 is the only career site dedicated to matching great developers with great jobs. Post your open dev positions on Careers 2.0 today. Reach the entire development community, all 15 million monthly visitors on Stack Overflow. The best part is you'll receive exceptional candidates, not just the massive pile of unqualified resumes you're used to wading through. We'll save you tons of time and headaches at Careers. When you're posting your job, you can even choose to receive a candidate's careers profile instead of just their resume, making your candidate sorting even easier. The guys at Stack Overflow believe in their product so much that if you're not incredibly happy, they'll refund your money, no questions asked. And to top it off, as a Hansel Minutes listener, you'll get a free Stack Overflow t-shirt when you purchase a job listing. To get your free t-shirt, use the code HanselMinutes and check out careers.stackoverflow.com. Once again, that URL is careers.stackoverflow.com. Well, and that feedback loop that you bring up is something that you always hear people who are really into, I would say blank-driven development, whether it be test-driven or behavior-driven or domain-driven, is this loop, this kind of a zone that they get into, whether it be the zone of the red-green refactor, but there's actually loops. There's kind of concentric loops within loops. There's not only the feedback loop between yourself and the tests and the acceptance test, but also the user stories, because I think this is the thing that we really need to get down to here, is that it's those user stories that the non-technical person understands that is driving the system. You know, people are writing software for business people who don't write code. And BDD is a way to take those acceptance tests, those expected behaviors that the person that's paying the bills, whether it be yourself or some suit somewhere, is asking you to implement. And then there's a feedback loop with that suit, with that business person, that can become extremely satisfying as well. They write the acceptance test, you turn it into a specification, you write the code that satisfies the specification, and then you come back and make sure that works, and then they can change those stories. Do you find, Matt, in your interactions that's the case, that there's a larger feedback loop that's also very satisfying?
I do. I'm reminded that we're in an audio medium, so I don't know if remembering pictures is a good thing. But Corey Haynes once drew that concentric circle that you just talked about. There's feedback with just the developer. There's feedback with, say, a QA. There's feedback to a business analyst level, and all the way back to the user level. So yeah, I mean, you definitely on the right track. Another thing I'll mention is behavior-driven development has been applied kind of at two different levels, if you will. There's the gherkin, or the given when then, versus the context specification.
Okay,
on the Ruby side,
let's slow down though and take that apart, because that's a word that I don't think everyone who speaks English as a second language is going to follow. So you said gherkin, and then given
right.
when then. Can take that apart for me.
Well, Amir and Mike can talk more about that, but there's several varieties of behavior-driven implementations. Usually they fall into two categories. One that emphasizes creating sentences using a given when then structure, which is called a gherkin syntax. And then there's the context specification side. Okay,
Amir, so how does that work? I say given something, when this is the case, then something, something, something.
Yeah, it pretty much, it's really helpful for business to maybe communicate in that vocabulary for those requirements that require something that needs to be disambiguated. So if there's something if there's some requirement that's fairly complex, users have a tendency maybe just saying, oh, it just needs to work, just make it work. And the given when then syntax allows the developer to maybe communicate on that level and really help them specify what they really want the system to do. And one criticism that I have with given when then is that we sometimes maybe overuse it for things like, a registered user should be able to log in. There's no reason to go through the given when then syntax. The requirement's fairly straightforward. So I don't think we should force that kind of grammar onto our EA counterparts if it's not needed. Context spec is a much deeper. Well, it's just a different approach. Maybe Matt can elaborate on context spec a little bit more.
Well, I think context spec is better for developers trying to write BDD. I think Gherkin-style BDD implementations give a lot more prominence to the sentence, which is good when you have business people writing those sentences. Whereas context spec breaks it down into simpler terms, really, where given a specific context, I specify this should happen. So it kind of it gives less prominence to the when, and you can kind of think of given and then mapping to context and spec. In context spec, your then might happen in your given, or it might happen in your then. It's a little bit more flexible. Another primary differentiator I want to talk about is in context spec, it's real easy to layer context, and it's just something you have to be really careful with because you can take it too far. But it's very simple to take a login context and stage a slightly different response from, say, an authentication provider saying that authentication failed. And then you can have slight changes in context expressed in a very dry, easy way by nesting those contexts.
So you're saying that the given, when, then style and context specification are two sides of the same coin?
I think so. I mean, both came about in a similar time era. Davis Stells, I believe, and Dan North. Both, I guess, sort of agree to disagree or go different directions. Sometimes people have said that Gherkin style or given, when, then is more appropriate for integration tests, whereas context spec is more appropriate for unit tests. I really think you can do either to solve either type of testing situation. I do think it's very definitive to say that Gherkin gives more prominence to the sentence. There's no doubt about that. In Gherkin, you express your spec as a sentence, whereas in context spec, you express your spec by declaring context and specifications. Now, we do turn those into sentences that look very similar to Gherkin sentences, but the sentence itself is not first class.
Okay. Well, this is a good opportunity then to dig a little bit into NSpec itself. This is a library is it built on top of NUnit?
Well, actually, that's a common misconception. What we've actually done is just taken the assertions from NUnit. We didn't want to write our own assertions for all the stuff, but it's a completely separate engine from NUnit.
Okay. So you use the assertion library, but you pulled that out and brought it over into your own world. So NSpec is on its own. So I could sit down, go file a new project, say, perhaps use NuGet and say, install package NSpec, and I've got everything I need. I didn't go off and get 15 different dependencies. It's pretty self-contained.
Yep, that's it. And if you want to use a different assertion framework like should, there's really no problems with that. I mean, NSpec, the way it works is that when an exception is raised, it's a failing test. So the assertions that were part of NUnit raise those exceptions, and we didn't want to go through and try to recreate or carve those pieces out, which is why we took on that dependency.
Okay. So I go and I write my first class library or take an application that I've already got and write a class that derives from NSpec. And other than deriving from NSpec and using the NSpec library, Amir, how do I start with my functions? I mean, if I've got an idea for a spec, what is my function going to look like?
So really, that's really it. If you inherit from NSpec, you've hooked into the NSpec runner. So when the NSpec runner executes, it will find all classes that inherit from NSpec. And usually the way I approach it, so one thing is that if you notice with NSpec, we don't use attributes at all, or we don't use attributes for any of our testing landmarks. So the way it works is usually the way I start my NSpec test is I keep it flat like I would with my NUnit specifications. So I will do it underscore, which means it's a test method, or specify underscore, which means it's a test method. So any method that starts with it underscore or specify underscore is considered a test.
Are you saying it, IT?
Yep, it underscore.
So it underscore. And then on your website, you've got given underscore and you've got when underscore. What are the differences between those?
So do we have that on our website still?
There probably are. There's really no difference. Given is as we mentioned earlier, is a keyword in Gherkin, given, when, then. to specify or to express this is a context. And so it's very natural to use given to express a context. I don't know if Amir just mentioned, but one of the important things that you have to decide pretty early when you're writing your first specification is what the name of the class is. The class itself is sort of a super level context. So you might say, I'm going to describe tic-tac-toe, and you would use the underscore notation or convention there. And that would be your top level context. So then when you go to write a method where you would actually put a specification, if you name your method it underscore, as Amir mentioned, that will be interpreted as a specification itself. So then somewhere inside that method, you would have an assertion. And that would most closely mimic an in-unit style where I would have a method with a test attribute.
Okay. So let me see if I understand this. So I go and I say, using NSpec, I'll say class describe underscore tic-tac-toe derives from NSpec. And then I would make a method. Maybe I would say void. How would I try to explain that a new game has a blank board? Would I just say it underscore new game has a blank board?
Or specify underscore. I usually try to start flat like I would with NUnit.
Mm-hmm.
So I'll start my specifications flat. So specify underscore and it underscore are considered constructs that perform assertions. So my first test would be maybe specify underscore tic-tac-toe game starts with a blank board.
Okay.
And I'll write a very flat. Write a very flat test similar to what you would do in NUnit.
Okay. And then so I've got the class and I've got the function. What kind of things would I want to say within the function, and what's the syntax I would use to make sure that I made a board and that it was blank when I made it?
So this goes back to just what would make a valuable test. I would probably say you would new up a tic-tac-toe game and assert that the board is empty. That would probably be the test that I would write.
But where does NSpec come into it? Is from the perspective of like, why did I need NSpec for that?
You definitely don't.
Because what I'm trying to understand is that when you read about BDD, and if you start searching around for it, you can see there are people who advocate using frameworks, and then there are people who advocate using very basic kind of almost no-op type methods. With they'll have a method called when or a method called specify. That doesn't really do anything except it holds on to a string and provides a little bit of context. So I'm trying to understand that with a spec runner and with the formalization that something like an NSpec offers me, some of it is convention, where I describe the class a certain way and describe the function a certain way, and some of it is value added by your assertion library and some of the methods you have, like it and should not be and things like that. So if I'm trying to figure out how to assert that this is the case, that my board is empty, and then start building up a bunch of tests, what are some main objects that I would use in NSpec to start building that, and where does NSpec's value become more obvious?
Okay, so the biggest value that NSpec provides you would be have you heard of the concept of one context per class in NUnit? Mm-hmm. So the idea there is that in your setup you have this context that you set up, and then the actual test methods that you write are just one-liners. You have one-line assertions in there. This
is kind of the idea of single responsibility principle, except applied to tests. Your test should have one bit of context that you should be testing, and then the functions all use that context, and they're careful to not do anything else that would change the context.
They don't manipulate it, and they just assert what that context does. Mm-hmm. So the challenge comes is there's this concept that I've seen is called context betrayal, where you've set up your context in your setup, you have a couple of assertions that use that context, and then you've got this little thing that deviates just the tiniest bit, but you don't want to spend the time to make another class, so you'll betray that context. You'll maybe do a little bit more interaction there, and then write an assertion right afterwards. So this context betrayal, it happens with NUnit because you have that flat hierarchy, and what NSpec gives you the ability to do is nest your context. So instead of having to pay the tax to create another class or do some inheritance hierarchy, you can use Lambda expressions directly inside of a method to elaborate on a context. It keeps your test dry, and you don't have to pay the expense of actually having to create another class.
Ah, okay. And see, now here we've come full circle because we were talking about this earlier when I asked the question about when I'm creating NUnit tests. Sometimes I find that I want to nest tests within tests and things become a little bit more complicated. But in fact, systems are complicated and specifications, having a hierarchy makes sense. So you're saying that, and of course, when I run this in the spec runner, I'm going to get a nice, hierarchical list of the things that run.
Yes.
With context being expressed via an indentation level.
Yes.
And there are lots of examples on the website that show that context and the output when you run the spec.
Now, is there a particular kind of BDD Bible or book that one should read? I mean, we can pick our tools, but is there a particular place that I should go that is considered the best place to get my head around how to think about this kind of testing?
I think, I don't know if there's any definitive resource. I wish there was. I think if you do some Googling and you look at Dan North's original article, and I believe his name is pronounced David Klemensky, I think it's Dave Estells that sort of imagined RSpec, and Dave who implemented a lot of it. If you go read the introductory blog post for RSpec, he actually walks you through writing a spec, and those are two really good resources.
Mm-hmm. Amir, do you think that the Dan North's introducing BDD article from back in 2006 is a good place to start?
Yeah, I think those are really helpful. And there's actually a couple of key points that I probably would want to go over. And just having these key points, it helps BDD click on what it's trying to do. And maybe if we got... So let's think about... I hate using this class, but let's think about a car, okay? When you write a test against a car, a non-BDD test would be a car has 4 wheels. It's a very simple test. Well, we can write the assertion on that, and you up the car, verify the count for the wheels is 4, right? So the slight change behavior-driven development makes is you don't test structure, you don't test whether the car has 4 wheels. You test what would happen. Why does the car need wheels? So maybe the test actually needs to be when driving a car, it says that it's drivable if it has 4 wheels. So I imply structure as opposed to testing the structure directly. So those are just the subtle things about behavior-driven development that it's tricky. And
I want to point out, I think this is a big insight for me too. Not specifying structure or not specifying just structure, but always specifying some element of behavior and then letting the structure sort of be implied. What I just thought of is back to our tic-tac-toe example. If you'll remember, I think the specification we discussed was pretty much structure only. So another good specification to maybe start with that's a better approach from a behavioral perspective is 2 players take turns or players take turns. So that would introduce the concept of players and a turn and the fact that it alternated.
Mm-hmm.
Or maybe another test, it may be a fairly easy test would be a board that is completely full is considered, the game is considered ended when when the board is full.
Right.
So it doesn't, so you can imply that it has 9 squares by verifying that the game is complete.
Yeah, and I think that's a really good place to end it, because I think that if you can find that language that clicks for you, that's where BDD starts to make more sense. I mean, like that example you just gave there, given that the board is full, when there are no moves left, then the game is over. This is the initial context, an event has occurred, and then there is some outcome. And even the simple idea of having expressive methods and expressive classes, and start building a sentence makes you realize that, writing tests about things like, the board has 9, little details, like kind of the board has 9 squares, and if the square's length, that's almost like not seeing the forest for the trees. And it seems like BDD really is about focusing on the forest.
Right.
So people can check out NSpec at nspec.org, and we'll put up links to some of the different articles that we've talked about, and people can download that and check it out. Thanks a lot, guys. I appreciate you talking to me today.
Thanks.
Thanks for having us. It's been fun.
This has been another episode of Hansel Minutes. We'll see you again next week.